Thank you, everybody. I'm super excited to be here. This is one of my favorite conferences. I've been here 3 times, never presented. It's a super big honor to get to be in front of all of you guys. If you have not met me, I'm Clint Sharp. I'm co-founder and CEO of Cribble. We're a sponsor. We have a booth up there, so come say hi to us. I'm here today to talk about literally a project I had to invent so they would let me keep coding. It's an open source project we're here to talk about with AppScope today. Super big problem that I think that we're solving, and we'd love to get your feedback on it and tell you a little bit about how we think the world could be a little bit different. So I'm going to say a few things that I think are not particularly controversial, and then maybe one thing that is a little bit controversial, and then we'll see. So operating a service today requires observability. And I'm sure there are people getting by without good observability, but really to operate a post-digital transformation, modern digital service, microservices, interconnections, etc. I really need to be able to ask and answer arbitrary questions of my data and be able to understand the end user's experience and how things fundamentally are secure. I think we can get a line around this. I hope so anyway. Operating a service, observing a service rather, requires high fidelity application level data. I cannot ask questions of data I do not have. And so if I want to understand my user experience or your user experience with my service, I need application level information to inform that. Hopefully high cardinality application level information that is per session, per user, to where we can dive deep into an individual user's performance and really try to understand fundamentally what's going on with that application. But also hopefully lower level information as well. Operating system level information, file accesses, network sockets open. We need a lot of information to understand truly how to observe a service in today's world. And most applications are not very observable. That may be controversial, I don't know, but in my experience, working with many of our customers and having been in this industry for a pretty long time, that the majority, infrastructure is pretty observable these days. There's a lot of out-of-the-box infrastructure metrics that tell us a little bit about what's going on with our infrastructure, but applications themselves, we're on a journey, let's call it, right? So there are some applications which are very observable. Many applications, though, are simply just not very observable at all. So how do we observe those applications today? Well, one, we have metrics. So show of hands, who has infrastructure performance metrics in their environment? That's pretty ubiquitous, right? Pretty much everybody's hand went up. CPU and IO and some network traffic and things about all the VMs that you're running and possibly the containers, etc. Generally not high cardinality, so it's really difficult to get to per. In fact, it's so not high cardinality that if you accidentally introduce a high cardinality dimension, odds are you're going to blow up your time series database and everybody's going to be screaming at you. So generally metrics are, for summary level information, running your dashboards. Everybody has these, right? They're very exploratory though. So I can navigate this data, I can query it, I can learn to understand my environment. Logs, who has logging in their environment? That's pretty ubiquitous, right? I'd say 80% of the hands went up. I have some way of grepping my logs or centralizing them into Elasticsearch or Loki or one of these types of tools. So logging is pretty ubiquitous. It is high cardinality. I can generally ask very detailed questions. It may take me a while to get the answers back, but I can ask very detailed questions in my logs and get information back. Distributed tracing. How many people have deployed distributed tracing? I'd say half, a third to half, something like that. That's impressive. I think this sample set, by the way, is a little skewed. I think more broad than the typical market is, right? I would say, distributed tracing, just gut feel, 25% penetration, let's call it, right? Certainly not 70 or 80% penetration in terms of applications. This is very high cardinality. It's less exploratory. I think of products like Jaeger and others, which are really awesome, but they're pretty on rails, right? I can navigate to a particular trace. That might be controversial. I'm sure that there are vendors here. Honeycomb is an example. They're very exploratory. They can do tracing and dig in. So different vendors give you different experiences, but by and large, tracing is not the most exploratory sort of user experience. Also tends to be a little bit longer time to value as people go instrument their code, etc. And then APM. Who has APM in their environment? A little bit, about the same, half-ish more. APM I generally define as kind of the last generation, but auto-instrumented, usually more metric-centered than high cardinality, sort of span type of events. Also another way. So what we have is relatively ubiquitous coverage of infrastructure and not really ubiquitous level coverage of application data. So the question that I would ask is how can we go from a ubiquitous set of exploratory, infrastructure and logging level stuff and bring application level information up to becoming ubiquitous so that we can ask and answer these questions of modern services. So how do we make application level data ubiquitous? So we have service meshes, good-ish adoption. I mean, we're seeing a reasonable amount of service meshes in the world. I tend not to see, this may be controversial or not, but I tend not to see them deployed simply for observability. They're generally being deployed for mutual TLS or service discovery or other reasons for solving the service mesh problem, and then I get some observability as a result of deploying that service mesh, but not generally the leading reason for that. eBPF coming along incredibly nicely. We saw from Splunk, the Explormill guys yesterday, great presentation. The Pixie Lab folks will be here tomorrow as well. Really excited to see that presentation. Their work looks really amazing. It's coming along really well. I think limited support for encrypted streams, harder with dynamic languages in eBPF. There's some pluses and minuses, right? Like Python, Node, these are harder languages to instrument in eBPF, but we're making a lot of progress. And eBPF may be the path to solving ubiquitous application level instrumentation. I could be a believer that is. But we here at Cribble and the authors of the Scope project really felt like there was another mechanism that we could use to gather application level information ubiquitously, and that's interposition. And so interposition is runtime agnostic. We're interposing a shared library between the application and the things that it's requesting. Things like TLS transactions or things like opening network sockets or opening files. That means we can do a black box instrumentation of nearly any binary, C, Rust, Go, static binaries, dynamic binaries. We can instrument nearly anything, and we can get to full payload, including TLS type of transactions. So we call this project AppScope. I'll give you guys URLs later. It's all Apache 2 licensed. You can go grab the bits. It emits APM-like data as metrics and events in open formats. So this is dog_stats_d format. This is TCP JSON, so just JSON documents, new line delimited on a TCP port. Very easy for anybody to go consume this. I've used, for example, things like FluentD or FluentBit to consume this information, or Telegraph to consume this information. You can also send this information to our commercial products. And we can scope any Linux binary simply by prepending this command scope. Immediately we'll start to see robust application behavior. We also collect application log information as sort of a side benefit. We also see all the log files that are being written and the data that's being written to those log files. And it provides the observability that you would tend to get from like a service mesh without having to deploy a sidecar, without having to deploy anything else that you're actually managing. So picture-wise, the application loads a shared library called libscope. That sits in between all of the system calls, all of the crypto libraries. That's what allows us to get to clear text payload, even on encrypted transactions. It's language agnostic. It works with anything, like I said. Very, very lightweight. And again, outputs data in open formats. So you're probably familiar with a lot of different, kind of instrumentation mechanisms of getting data black box out of applications. One would be an example of strace, right? Probably everybody's used strace over the course of their career. Super detailed information. Sometimes it's the only thing that you've got in order to try to understand what this application is doing. Tends to be very verbose, very hard to read, but it's awesome because it works with just about anything, right? I can run strace on just about any binary. We're sort of like that in that we're seeing system calls like strace is. We're sort of like TCP dump because we're seeing wire data. But we're seeing wire data, including clear text payloads, even if the application has encrypted it. And it's sort of like a man-in-the-middle proxy because we actually understand protocol. So we understand HTTP, and we can see HTTP and HTTP2 level events. And so we can understand kind of what that application is doing. Okay, with that being said, let's actually show real product. Woo, all right. Always happy that worked. It's on the network, so we'll see how it goes. So right now what I'm showing you is I'm going to be showing you Scope, the command line experience. And so Scope has a single user experience that we can use to just interrogate any running application. It can also be deployed as an agent, which I'll show you guys in a little bit. So to start with, this is running in one of our sandboxes. You can actually run this yourself. You can go to sandbox.cribble.io and go run the AppScope fundamental sandbox so you can reproduce everything that I'm doing is all reproducible completely online. So to start with, I'm going to send it. I lied. There we go. All right. High latency. Well, it is live. All right, so we'll try, and we'll just hope that I can type well. Unfortunately, it is over the internet. Look at that. Let's see what my latency looks like. Ooh, yeah. All right, well, if you're on the speaker Wi-Fi, if you wouldn't mind getting off. All right. JK. All right, we'll see if that comes back later, and if not, then we'll try to make do what we're having. So I'll show you the output of the agent side deployment, and then hopefully latency will come down enough that I can actually do live demo, which I was working just fine about before all you guys came back, actually. Amazing how that worked out. Okay, so we are sending data from AppScope over to Elasticsearch and Prometheus. AppScope outputs metric data. It can output that in dog.statsd format. You can send that data to CribbleStream, which is our commercial product. In this case, CribbleStream is receiving that data, translating that data to Prometheus Remote Write, and translating that data to Elasticsearch's bulk ingestion API. And we're taking all the data that's coming out of AppScope today, which hopefully we'll be able to show you interactively in a minute, and sending that data to both Grafana and to Elasticsearch. And so as we start to look at the data in Grafana and we start to look at the data in Elasticsearch, we can see pretty detailed information about what's going on with these applications. In this case, I have deployed Scope in Kubernetes as a mutating emission webhook, and so we're seeing all new containers that are being started. We're automatically instrumenting each new container with a Scope binary, so we're seeing all the activity from what's going on inside of that particular container. In this case, we're actually scoping an environment that has Elasticsearch in it, it has Cribble in it, it has Prometheus in it, and we're seeing metrics actually from Prometheus, from Elasticsearch, from Grafana. We're actually instrumenting, it's somewhat meta, in that we're actually instrumenting the applications that we're sending data to, sort of full, not a really good term for that, but anyway, kind of full circle there. And so we're seeing HTTP level requests. I can see that curl is requesting data from Elasticsearch. I can see Elasticsearch receiving HTTP requests on the Java process. I can see Kibana, their node process. I can see the Prometheus Go process. And we're seeing the number of HTTP requests that are going on in that environment. I can also see that there are a number of errors that are happening in this environment. I have kind of a built-in troubleshooting use case in this, but I probably don't have time on stage to walk all the way through each one of the finding the actual real problem. We're showing client bytes, we're showing server bytes, we're showing how much network data is being transmitted, we're showing how much CPU is being consumed by each process. So you can see each process that's being started is getting its own time series for performance of CPU and IO. File opens, file closes, file reads, and file writes. So this is metric level information, and so that's generally summary level information that we're outputting. You can send it to any TSDB and work with it interactively, whether that's Prometheus or Mimir, or whether you're sending that to Splunk or SignalFx or Datadog. Pretty much any time series database can receive this type of instrumentation. But we're also outputting high fidelity event level information as well. So in this particular chart, I'm looking at the number of requests going to Elasticsearch, going to our API server, going to Kibana, and you can see this is split by URI. So I'm showing you in detail, these different user endpoints. I'm seeing the Elastic bulk ingestion API where data is being posted to. I can see, data being written to Prometheus on the API v1 write endpoint. So we're grabbing this information out of unmodified Linux binaries, all completely in user land. So this has no kernel level interaction. This is all done, completely on the user land side. And we're seeing high fidelity application level information. We can actually get to up to and including full payload. So we can see and parse payloads and understand in detail kind of what's coming in and out of that HTTP based application. And you can see kind of the most popular endpoints that we're collecting here, the bulk endpoint, the Prometheus endpoint. You can see us kind of sending the data in the environment and kind of bootstrapping that ourselves. So I don't know if maybe I've gotten a little bit lower latency. I have not. Cool. So I have a really cool interactive demo showing you how to scope everything from Python to Perl to any sort of unmodified C binary. Unfortunately, the latency is too high, and so I'm just going to have to wave off on that. It's probably just not going to work, even though it was working fine. Oh wait, yeah, okay. We're just going to skip it. All right. So I'm going to wrap up my presentation early. With that, let's talk a little bit about what we can do with this type of information. So with ubiquitous application level information, the problem that we're immediately going to create is like, well, it wasn't like you didn't already have enough metrics or enough logs or enough, whatever. So how do we actually deal with the upcoming deluge of data that having ubiquitous application level information is going to give us? As an industry, we think there's a number of places we can go with this. One is, obviously the data can go to your existing metrics and log solutions. So you can take kind of ubiquitous application level information, send it to Datadog, send it to Prometheus, send it to Elasticsearch, send it to Splunk, send it to wherever your tool of choice happens to be. AppScope is emitting this in open wire format so that you can send it anywhere you would like. We don't feel like you have to send it to Cribble. We're donating this to the industry. We want everybody to be able to make maximal use out of it. Although it's going to be what amounts to a metric shit ton of data, right? Like you're going to be struggling dealing with kind of this amount of information. And so there's a couple of newer approaches that we are pioneering at Cribble that we think are going to help us deal with the massive deluge of data and be able to process significantly higher multiple amounts of data than we can process today. The first would be edge persistence, and so we are starting to roll out a product that allows you to persist circular buffers of high fidelity data at its origination point and federate searches to potentially tens to hundreds of thousands of endpoints in order to give you access to this level of high fidelity information. Free capacity at the edge is being used for doing that data processing. And if you look at kind of, Datadog did a survey in like 2020, the average utilization of a Kubernetes cluster CPU-wise is sub 30%. So there are a lot of spare CPU cycles sitting out there on nodes not being utilized today that can be used for observability and telemetry data processing. And so we think that this is a really interesting, sort of new architecture that we're looking to pioneer. And the last additional thing that we're talking about is this concept of an observability lake. And observability lakes are a little bit different than just kind of your standard data lake. Obviously, it is a data lake, but observability lakes have data in open formats, but also have a wide variety of data. So start to think about, we can start to persist things like configuration data, or things like full wire data, or full payload capture data that may end up in the observability lake that gives us the opportunity to go back in time and understand what may have been happening with that application. Dating back to about a decade ago, when before I was a vendor and I was a practitioner, one of the things that was I wished I would have had, like every time the application crashed, I wish I could have had a time scrubber to go back in time and see all those payloads. Just if I would have had an hour's worth of payloads, I knew within an hour that application was having a problem, and I could have decided to egress that hour's worth of payloads and what I wouldn't have given to know what actual request was made that ended up creating that error. And today we don't really have access to that level of payload information. It's too difficult to egress that level of information, and we think that there's a future whereby which we can have access to full payload information for future troubleshooting and diagnostics. And then we can also replay that data to other solutions at a later time. So the lake can also be like a really nice place where we're just stashing massive quantities of observability type of data, and you may not analyze it in place, you may analyze it in place, or you may end up moving that data to something that is a more appropriate sort of analysis solution for that data. So with that, and I think my demo's sort of busted, but happy to show people more. I should have had a more local copy. It was actually working, but we'll be at the booth if anybody wants to come by and see kind of interactive.
You want to flip to the guest network.
Oh yeah? Okay.
As crazy as that sounds.
Let's try. Let's see what happens. No, there should have been more for guest. All right, let's see. Who knows?
Got to give a round of applause for a live demo here. We're doing it live.
There we go. Hey, what do you know? All right. Hey, you want to see a demo? All right, let's do it. All right, cool. All right. So first thing I'm going to scope is just bin echo. Bin echo is a ludicrously simple utility. And so now I'm going to run scope metrics, and you can see a little bit of detail about what we're collecting, right? We're collecting that a process was started, it consumed this many microseconds of CPU, there was this many kilobytes of RAM consumed, this many threads created, this many file descriptors created, this many files opened, etc. And we also keep track of events. So we can say, look, there was a console message true printed for that particular command. So now what I'm going to do, I'm going to scope something a little bit more old, and I'm going to dial it up to 11. If there's any Spinal Tap fans, we'll put verbosity up to 11. And what I'm going to run is I'm going to run Perl, and I'm going to say, let's print Monitorama. Cool, I misspelled it. Probably still misspelled it. Now if I look at metrics, we're capturing even more detailed metrics. So we're keeping track of all the different files that it's tried to open. We can see that it's trying to open a number of files and actually erroring, attempting. I don't know what Perl is doing. I haven't used Perl in a very long time, but it's interesting to see what it does. We can see how much CPU it consumed, how many file descriptors it opened. And if I look at scope events, we actually see that it opens up urandom and dev null. I don't know what it does this with every execution of Perl. I don't know what it's doing with dev null, but maybe it just likes to have a copy of that written there. We can also pick up log information, which I think is super cool, because applications write log data everywhere. And oftentimes I don't even know where that application is writing logs to, and I actually have to know that it's being written somewhere, fundamentally on the file system. So if I look at this simple little log script here, I'm opening two files. One, I'm opening a text file, and so we're not going to pick up the contents of data being written to an arbitrary text file, but we have a simple heuristic that if it has log in the path or it has log in the name, we'll automatically pick up file writes that are being written to log files. And so now I'm going to scope Python 3, and I'm just going to run log py. And if I look at scope events, Cool, I can see that I did indeed log will see this string to this particular file. So this is pretty cool. So like in a couple of minutes, we have scoped a C application, we have scoped Perl, we have scoped Python, and we've gotten reasonably interesting information. So one of the things I'm gonna run in the background is I'm gonna scope Nginx. And then over here, I'm just gonna start another terminal here. I'm gonna say while true, let's do curl HTTP localhost, and let's sleep 1, and then let's done. Oh. Might just help if I spell localhost right. Okay, so now I'm running curl in the background, just kind of on a loop. We're just gonna go request some information. We're gonna see what comes out of that. And so if I scope manually over here, I'm gonna scope curl. And this time I'm gonna choose HTTPS because I wanna prove that I can actually look at encrypted data that's on the wire. And I forgot here, I'm actually going to ignore that it's an invalid certificate. Cool, and so if I go look at scope events now, you can see that there's an HTTP request made to localhost. You can see that there is a response. So let me go look in detail at what this response is. So I'm going to go scope events. Whoops. Ah, shoot. Nope, not that. Events. There we go. Oh, shoot. That was right there. Nope. One more. There we go. And so I can see in detail what HTTP level protocol information we have captured. We've captured that it's an HTTP 1.1 request. We requested that it's a GET. We can see that it was done over HTTPS. We can see what user agent was captured. And fundamentally, all this data is just JSON data. So we can egress this data to anywhere. And in my example where I showed you Elasticsearch first, this is the class of information that we're sending out there. So one thing I'm going to do is I'm actually going to capture payload information as well. So I'm going to do scope run -p, and I'm going to say curl HTTPS localhost. Nope, forgot -k. All right, so now if I look at, again, I'm going to run scope flows. So we also keep track of the network flows that each application is making, how many TCP connections or UDP related information that we have, how many bytes are going over that. And if I want to see like what was sent out over that, oh, whoops, flows and this guy. I'll show you that the GET request was made, and again, this is over TLS. So I use this shit all the time because I can't figure out what my own application is doing, and all I really want to be able to get to is just like what HTTP request was made, what was actually on the wire, what was coming back. Oftentimes I find myself going into my application and writing logs for this, and post-scope I find myself just running scope on that application and seeing what's coming out over the wire and seeing what's coming back and making it really, really trivially simple to see, kind of the output of what's being sent out on that connection and then what's being sent back in on that connection. So we're seeing full kind of payload, wire data that's in there. So I was going to show you all this first and then show you the examples of how that all gets consumed. We kind of did that in reverse, but it's good. Thanks to Pete for helping me find a Wi-Fi that was working. And so just covering up on next steps, I think we may have a little bit of time for Q&A or I may be over. If you think this is interesting, stars on GitHub, please. It's a really cheap call to action, but we'd love your stars. I think we're not that high in stars. We haven't really promoted this much. This is kind of the first time that we've come out to talk about this product and this project. This product has been in development for about 3 years. It's battle tested. It runs on the inside of our cloud. It's guaranteed to cause weird problems in your environment. Please go test it. Make sure you run it in a lower environment first before you promote it to production because it'll probably work fine, but I would test that stuff first before you go kind of rolling this out full and on in production. Anytime you're doing any kind of low level instrumentation, my strong recommendation would be test this in lower environments first, but we'd love if you would just go stars on GitHub to start with. We have online sandboxes at sandbox.cribble.io. Everything that I was doing in that sandbox there's actually an interactive tutorial with documentation that will walk you through exactly the same steps I was just taking with that same demo. So you can actually go just try it yourself. You can also download the binary from appscope.dev. You can also grab the same Kubernetes demo that I did, is also hosted out in our GitHub. If you think this project is interesting, we're hiring a product manager for this product, so please come see me. We would love to hire you. And then we're also a commercial company. We've got a lot of products to sell, and so we've got a booth out there. And if you think that any of this stuff sounds interesting, we'd love to talk to you up at our booth. And so that is it. And I think, do we have time for Q&A?
We sure do.
All right.
Awesome. Do we have any questions? Got one right here. And then
Any roadmap to do like API and try to understand internal functions, or common libraries? Since you're preload, you could, in theory, get in front of common libraries, to do up above syscall level instrumentation.
Yeah, so the question was, any plans to move into APM and give kind of function level, et cetera? I think there's a couple of areas of collaboration in open source land here, right? So one is that I think there's some really good potential collaboration between us and a number of the eBPF related projects in order to use us as the user land component rather than trying to get at everything from kernel space and try to get into user space. Use our user land and use eBPF to push ours, instrumentation into user land. And I think there's also other collaboration points where we may look to, for example, the OpenTelemetry project, who already has some pretty good auto instrumentation. I don't think that we would look to go build the auto instrumentation ourselves. I think there's a variety of projects out there that are attempting to do auto instrumentation. And then one of the problems with them doing auto instrumentation is then it's oftentimes difficult for them to get themselves into, for example, Node.js and to kind of jam themselves in. And I think we could probably use AppScope where we're sitting. We do a light amount of bytecode instrumentation today, by the way, in order to get to clear text payloads of Java applications. So Java has its own TLS implementation, and so we have a minor amount of Java bytecode that allows us to get inside there. But I don't think we would likely build that, but I would love to collaborate with other projects that already have that information in order to use us to make it more easy to get that into those areas. It's a great question, though.
Got one right over here.
Yeah.
Yeah. So you mentioned Java and bytecode. You can do some bytecode research to get kind of traffic. How about the Go apps, where everything's statically compiled and your system calls just have the encrypted data on the wire?
Yes. The question is, what about Go apps? Back to my demo here. So if you look at, for example, scope, if I bat HTTPS Go here. So this is a super simple Go application that's making an HTTP request to my Nginx web server that's here. And if I look here on my file system, it's called Go HTTPS. So just to prove that this runs, scope run Go HTTPS. Okay, so it picks up the same payload. And if I go look at scope events, we can see that indeed we are instrumenting Go HTTPS. So we do support Go. Go is really difficult to do, and if that is of interest to you and you like to talk about low-level language runtimes and how weird Go is about all of its internals, I've got a couple of developers who will talk their head off for hours about how they ended up getting that done. But we work with any statically linked binary or any dynamically linked binary.
I see one right here.
Yes, hello.
Have you measured the performance of a data running scope versus without it?
Yes, the question is how we measure the performance overhead. We quoted at about 2%. And so yes, we have. That being said, you can tell from its 100 and something GitHub stars, it is not ubiquitously deployed. So I'm certain that there are edge cases there where we're not going to meet that SLA. But in general, from our, we have a robust unit and integration testing environment that tests this actually against the majority of the Linux user land as we're running through our test set. And so we know it not to crash in most places, and we know its overhead to be low. That being said, it is version 1.1 instrumentation software, so take that with a grain of salt.
They've got one up top here.
Yeah.
Yeah, so I see you have native support for HTTP, you understand HTTP. Do you understand something like gRPC or other protocols?
Yeah, so the question is, do you natively understand gRPC or other protocols? gRPC is really, really difficult to man in the middle. And this thanks to the protobuf guys for building a wire format that doesn't self-describe. Like, you have to have the schemas on both sides. So the answer is, can we eventually do it? Yes, we do not today. It's something that's definitely of interest to us, but it is not built. I don't think it would necessarily be hard. The place where I might move that intelligence, we also have the ability to egress full payloads through our wire protocol to other analyzers as well. And so the right place to do that might not be in the library itself, but might be in a third party that's receiving that payload and figuring out how to do the decoding of that information.
All right, we're there. I think there was a follow-up question here.
Yes. One more, and there's one more over there as well. Yes.
Related to the load question, for someone that's got a CDN type payload where they might be doing 40 plus gigs on a machine, obviously Cribble Stream could sample later.
Yep.
Is there any sort of source sampling to avoid some of the, to only look at so many of the syscalls or the connections, or would you just suggest then, are there any built-in sampling or other sort of, be lower overhead for really high volume workloads?
Yeah, so the question is, for very high workloads, can we sample or another way dial back the instrumentation such that we're not, we would be able to lower performance overhead We do some of this on our own in terms of like all the data that's being moved between, you know, the application library and then the central process. There's a bunch of ring buffers and so if those overflow, we'll miss samples. And so like we will default to data loss rather than breaking your application, as an example, right? So there's we can have a lot of discussion about the internal design about how data moves through the library. We may be able to do some of that. I would have to get back to you. I'm not 100% sure. And if we don't, we probably should. And it's a pretty good idea. And there was one more question over
Yeah, we'll do this last question here.
Will it work on BSD?
Will it work on BSD? I haven't run BSD in so long. Right now I'm going to say it's Linux only. The approach, in theory, should work on BSD.
I mean, it's open source. You just clone it.
Sure, yeah.
Clone and build it, right?
I'll tell you what. Why don't you try it, and then you let me know. You'll let me know. That'll be great.
Awesome, great. Thank you so much. This is a fantastic talk.
Thanks, everybody.